Hello, I'm Ben Kim, and today I'm going to be teaching you how to calculate a definite integral using Riemann sums. So what we have here is we're trying to find the value of this definite integral as 1 goes to 3 of x squared minus x plus 1 dx. Alright, so as you can see I have the equations set up here, and what we're going to do first is as you can see we have our a and our b, so we're going to find our delta x. So delta x is going to be equal to b minus a over n, so that's going to be equal to 3 minus 1 over n, which is going to be equal to 2n. And after that we're going to find our c sub I, so it's going to be 1 plus our delta x, which is 2n, 2 over n, my bad, sorry, times I, which is equal to 1 plus 2i over n. And after we do that, we're gonna plug it into the function fc sub I. So what we're gonna do is fc sub I equals, and we're basically gonna plug these values into our function x squared minus x plus 1. So what it's gonna be 1 plus 2i over n squared minus 1 plus 2i over n plus 1. And we're going to solve for this, and we're going to end up foiling this, so it's going to be 1 plus, let's see, 1 plus 2i over n, 1 plus 2i over n, minus 1 plus 2i over n plus 1. So this is going to be 1 plus 2i over n plus 2i over n plus 4i squared over n squared minus 1 minus 2i over n plus 1. So we can just cross this out, so it's going to be, and cross those ones out, so it's just going to be 1 plus 2i over n plus 4i squared over n squared. Alright, sweet. And then after that we're gonna have to set up our we're gonna have to plug all this so this value, or this basically equals the function fc sub I, right? So what we're gonna do, we're just gonna go back to the equation and we're gonna plug it back in our summation. So there's a limit of n goes to infinity, summation, or the sum of 1 2i over n plus 4i squared n squared times 2n, which is our delta x. So after that, we're basically going to solve it. What we can do is we can just put our sum inside and take this over here. So it's going to be the limit of n to infinity of 2n minus n of 1 plus, and we're going to have three different summations here. Equals 1, 2i over n plus 4i squared over n squared. So what we can do after that is basically we're just going to simplify it, or not simplify it, but we're just going to take out everything else except the n, the i's. So this is gonna stay the same, plus n is 1 of 2n over here and I right here, plus 4n squared. So this is what it's gonna look like. Alright, so from here, we're just gonna, since we know the summations of I, we're just gonna basically use those and just substitute. So it's gonna be, as the limit approaches infinity, 2n times n plus 2n of, and then we know this value is equal to n plus 1 over 2, right, plus 4n squared, and then we know the summation of I squared is equal to n plus 1, 2n plus 1, all over 6. So after that, we're gonna just distribute the 2 to every number, like that. So it's gonna be limit of n 2 plus 4n squared and n plus 1 over 2 plus 8n cubed and n plus 1, 2n plus 1 over 6. So this is basically how it's going to look like. Just go to the back. And then we're going to have to simplify it even more. So the limit as n approaches negative infinity of 2 plus 2 n squared plus n squared plus 4/3 times 2n cubed over n cubed. So basically now we can just we can simplify even more. So it's just we're basically gonna plug in now. So it's just gonna be 2 plus 2. It's gonna be 2 plus 2 times 1